Hi, this is Dave Lipscomb. I am your Math Olympiad teacher, and I am here to teach you today specifically about divisibility rules of numbers by 2, 4, and 8. You'll find on the Math Olympiad that there are a number of problems where you need to quickly discern whether or not a number is divisible by another number, another smaller number, typically numbers like 2, 3, 4, 5, 8, 9, 10, and 11 are some of the rules, the numbers that have rules that you can quickly learn. So today we're going to focus on 2, 4, and 8. These numbers, the divisibility rules for these three numbers are very similar. So watch how they're similar, watch how they're different, and let's get going. One of the important things that you need to know for the Math Olympiad are divisibility rules for numbers, both small and large, and needing to know whether a number is divisible by, say, 2, 4, or 8 are rules that are pretty similar that I can teach all in this one video. The key is to quickly determine whether or not a number is divisible by 2, 4, or 8 without having to go through the full division. Some of these you may know, like this first one. You may or may not know this rule. But, for example, the rule for the divisibility by 2 is a number is divisible by 2 if the last digit is divisible by 2. And that's all you need to look at. So some of you may know this rule as a number is divisible by 2 if it's an even number. That would be that'd be the equivalent statement. But let's just look at some examples. The number 6, for example, is divisible by 2 because the last digit, it's only got one digit, so the last digit, 6 is divisible by 2. So it is. Now let's look at the number 149,420. All we have to do is look at that last digit, 0. And because 0 is divisible by 2, the numbers that are divisible by 2, remember, are 0, 2, 4, 6, and 8. So those are the single digits divisible by 2. So 149,420 is divisible by 2. It's also true for negative numbers. So the number negative 42 is divisible by 2 because the last digit is a 2, which is divisible by 2. And then finally, the number 123,456,978 is divisible by 2 because an 8 is divisible by 2. Now, the divisibility rule for 4 is pretty similar with a slight exception. A number is divisible by 4 if the last two digits are divisible by 4. So let's look at this. So in the number 12, instead of looking at the last digit, we have to look at the last two digits. And the last two digits in the number 12 are 12. And 12 is divisible by 4. And if you don't know how to do that, you can just divide 12 by 4 and go longhand. Similarly, the number negative 628, which would be the same as the number 628, is divisible by 4. What do? We go to the last two digits. The last two digits are 28. And we know that 28 is divisible by 4 because that goes into 7. 4 goes into 28 7 times. Similarly, for 444, we look at the last two digits and we determine that the number 444 is divisible by 4 because 44 can be divided evenly by 4. And it goes in 11 times. And then finally, the number 1,624,028,402 is divisible by 4. Do we have to look at the whole number? No, well, it is not divisible by 4. This should have been an 8, sorry. 1,628,408 is divisible by 4 because we look at those last two digits. And the number 8, 08, is divisible by 4. It goes in 2 times. Okay, can you guess what the rule for divisibility by 8 is? It's going to be similar, except a number is divisible by 8 if the last three digits are divisible by 8. Okay, so here the number 16 is divisible by 8. Well, what are the last three digits? Well, we don't have a third digit, so we just take the last two digits. Well, a third digit is kind of a 0, but we'll just ignore that. We just take the last two because we don't have 3. And 16 is divisible by 8. Similarly, the number 12,016 is divisible by 8 because if we take the last three digits, the number 16 is divisible by 8. Goes in twice. We can look at the number 999,872. Look at those last three digits. 872 divided by 8, we get 1,807,072 goes in 109 times, so that number is divisible by 8. And then finally, 31,232, we got to look at those last three digits, and we get 8 goes in 2 times. 2 times 8 is 16, 72, 29. So, why do we need to know these kinds of divisibility numbers? Well, on the Math Olympiad, you'll have problems like this one, where Khadija is thinking of a 5-digit number, and we're not going to do this problem. We're going to do this problem on a different video, but you have to be able to quickly figure out numbers that are divisible by 8, and also by 11 and 5. We'll go over those numbers in a separate video. I put all of these numbers together, though, 2, 4, and 8 in this video because the rules are very similar. Divisibility by 2, we look at the last digit. Divisibility by 4, we look at the last 2 digits. And divisibility by 8, we look at the last 3 digits.